We're going to take a look at evaluating trig functions today, so sine, cosine, tangent, and their inverses, as well as secant, cosecant, and cotangent. Here's some advice from last year, really to show you how important this lesson is for us. This stuff's going to stick with us all through the year. We'll be looking at the unit circle and how we can use the unit circle to evaluate trig functions. And here just pointing out again that this doesn't go away. Pretty much every single quiz we have is going to have one of these questions on it. And the reason for that is because it shows up in the context of many other problems that we'll look at. Okay, when you first learned about trig, you learned about how to evaluate for an angle with a right triangle. We have the adjacent side, the opposite side, the hypotenuse. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Well, we're going to put this on, and in this class, I really recommend just sticking with the unit circle. If we can figure out the unit circle, we don't need to worry about those triangles at all. So unit circle is called a unit circle because it has a radius of unit 1. So you can see the radius there, 1. We have the distance x and the distance y. And we can see from our triangles that sine then, since that's opposite over hypotenuse, ends up being y over 1, or y. So the y coordinate gives us sine, the x coordinate gives us cosine, and tangent is given by sine over cosine, which is y over x. All right, so we have our 90-degree angles. We're using radians, so we have 0, pi over 2, pi, 3 pi over 2. If we take a look at the relationship between the unit circle and the sine graph, we start here with 0, and we can then go up to an angle of pi over 2, and the y value at pi over 2 is 1, so the sine curve has made it up to 1. As we move around then to an angle of pi, about 3.14, we're back to 0, negative, and then back to 0 again at 2 pi. So going around this unit circle, plotting the y values to the angles, we end up with the sine curve. So for these 90-degree angles, we have sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1. These ones we shouldn't have to draw the unit circle to come up with. These are ones that we really need to memorize. Cosine is the x distance, so when we're at an angle of 0, we're out 1 unit. At pi over 2, we're up 0, or sorry, we're out 0. Cosine of pi, we're left negative 1, and so on. And again, these are ones that we need to have memorized. We shouldn't have to look at the unit circle to come up with these. Okay, helps to know the relationship of all the other trig functions in terms of sine and cosine. If we do, then as long as we can find sine and cosine, we can find all of the others. If you ever divide by 0, then your function is going to be undefined. So cosecant of pi over 2. Well, cosecant is 1 over sine. Sine of pi over 2 is 1. 1 over 1 is 1. Secant of pi is negative 1. And you can take a moment to try to think through all of these in terms of sines and cosines to determine how we came up with all of them. Okay, here's the rest of the unit circle. I want you to notice that there's some patterns here. If we start out at an angle of 0 at 1, 0, and we move counterclockwise, we move up to angle pi over 6, pi over 4, pi over 3. These are our 3 intermediate angles that we have values for that we tend to memorize. We remember these ones. Now, you can always refer back to the unit circle. You can draw out the unit circle and figure these out because there's some really nice patterns that occur. If we look at the x-coordinates, we go from 1 to root 3 over 2, root 2 over 2, 1/2 to 0. Looking the other direction, look at the numerators. We go 0, 1, 2, 3. When we just throw a square root over the top, technically we have square root of 1, but square root of 1 is 1. And if you look all the way down at an angle of 0, if we continue that pattern, we get root 4 over 2. Well, root 4 is 2. 2 divided by 2 is 1. So that pattern actually holds for all of those we've just simplified. And then we can move up counterclockwise with the y values. 0, 1, 2, 3, and then we get to our 1. And if we continue around the circle, these are just coordinates that we're looking at, x values and y values. And we have a lot of symmetry here. So if we go from an angle of pi over 3 over to an angle of 2 pi over 3, we are now at a negative x value and still a positive y value, so make the 1/2 negative and keep the root 3 over 2 positive and continue around. And we can keep going around and around the unit circle. And keep in mind also that when we make it all the way around, that's 2 pi. So the coefficients of all of these angles should be less than 2, so you can use that to help yourself figure out the fractions that apply in each of these quadrants.